Hello, how are we doing? I hope we are well. In today's lesson we're going to be moving on from Pythagoras' theorem and we're starting a new topic all to do with ratio. So by the end of this lesson I would like us to be able to understand ratio notation, and also I would like us to be able to simplify a ratio. Okay, the first thing I'm going to get us to think about is making a glass of orange squash. So there's lots of different strengths you could have. If you only put a tiny bit of squash in and loads of water, you're going to get quite a watery drink. And then on the other end of the spectrum, if you put loads of squash in and just a little bit of water, you're going to have a very, very strong drink. That's going to be almost too hard to drink. So I probably like a squash somewhere in the middle. Okay, let's consider two drinks. Let's consider drink A and drink B. So these are two different glasses of orange squash. So this one has 1 part orange and 2 parts water. And then this one on the right, it has 1 part orange and 3 parts water. I wonder if you can predict what question I'm going to ask you in a minute. Okay, so there's some maths that we can use to explain what we're seeing here. That maths is called ratio. So this first drink, because there's 1 part orange and 2 parts water, we can say this drink has been made in a ratio of 1 to 2. Well, 1 means the orange and 2 means the water. So similarly, drink B, obviously it'll be 1 part orange, 3 parts water, so it's 1 to 3, that's how we say it out loud. And the question I'm going to ask you is, what drink do you think would be stronger? So if you made these drinks, which would be the more orangey drink? Okay, so drink A would be stronger because it's got less water diluting it down. So I'm going to ask you a similar question with two different drinks now. Let's consider these two drinks. Okay, so drink A or drink B. I'm going to get you to think, what drink do you think would be stronger, or are they the same? So have a think. Well, first of all, let's consider these as fractions, and I'm going to show you how the ratios can link to fractions later on. Drink A, well, it's got 1 out of 3 parts are orange. Drink B, well, there's 6 parts in total, and 2 out of 6 are orange. So do we see, thinking back to our work on fractions, do we see that actually they've got the same fraction of orange in each drink? Yeah, because 1/3 is exactly the same as 2/6. They are equivalent fractions. Because there's the same proportion of orange in each drink, we can say that these ratios are equal as well. 1 to 2 is exactly the same as 2 to 4. They share the same proportion. They are equivalent ratios. I know that because both parts of my ratio, so 1 times by 2 gives me 2, and 2 times by 2 gives me 4. Okay, so these ratios are what we call equivalent. I'm going to speak a bit more about equivalent ratios now. Look at this bar. So what ratio would this bar represent? So at any point, just pause the video if you need to. So I'm asking you, what ratio does this bar represent? Well, this bar represents a ratio of 6 to 4. It could mean anything, but let's just think in terms of orange squash again. So this is a very strong drink. It's 6 parts orange and 4 parts water with 10 parts in total. I'm going to show you that there's lots of different ways I could write this ratio 6 to 4. Have a look at the image above. Do we see that if these were both drinks, they would taste exactly the same? Okay, because they've got the same proportion of orange juice. With 2 bars of the same length, okay, they've got the same proportion of orange juice. Okay, but this ratio is 3 to 2. So let's think, how do we know that 6 to 4 is the same ratio as 3 to 2? Well, how are they equivalent? Well, if I divide one side of my ratio by 2, I must also divide the other side of my ratio by 2. So it's kind of like when we simplify fractions. Okay, if you do the same thing to both sides, those ratios will be equivalent. So it doesn't only just work when I divide, it also works when I multiply as well. Do we see that this bar represents an equivalent ratio? Think about what equivalent ratio this bar would represent. Well, this represents 12 to 8, and I know that they're equivalent because if I multiply the left side of my ratio by 2 and the right side of my ratio by 2, that's going to give me an equivalent ratio. And I can see, but just by using these bars, that all 3 of these ratios, they mean the same thing. They represent the same proportion of orange juice in that glass. They're just written in a slightly different way. So if you look at this text I've written for you at the bottom, this is really important. Ratios stay equivalent if both sides are multiplied or divided by the same amount. So it only works when you're timesing or dividing. Ratios are not equivalent if you try and do the same thing with adding or subtracting. So this works, but it's only when we multiply or divide. And you can see why that happens by this bar. Okay, so let's talk about a new style of question. So simplify means find the lowest equivalent ratio without going into decimals. It's so similar to simplifying fractions. So let's say if I've got a ratio 9 to 12, all I'm going to do, I'm going to keep dividing it until I can't divide anymore without going into decimals. So what number goes into both 9 and 12? Well, I know that both of these numbers can be divided by 3, so that gives me 3 to 4. I cannot divide anymore without going into decimals, so I can stop there and I have simplified. What I'd like you to do, could you please pause the video now and see if you can simplify the ratio 18 to 24, please. Okay, so there's a couple of ways you could have done this. So 18 to 24, I'm asking myself what numbers go into both 18 and 24, so what can I divide these by? One way you could have done it is divide both numbers by 3 to give me 6 to 8. Okay, I don't just stop there though. Okay, so I've made it slightly simpler, but to fully simplify it, I need to divide it until I can't divide anymore. I can still divide 6 and 8 by 2, so that means that gives me 3 to 4. And actually, both of these answers are the same, even though the questions were different. Okay, so there's another way you could have done this 18 to 24 one, and I've just written that working there. So one way you could have done it, you could have just halved both sides and then divide both sides by 3. So for your classwork today, I would like you to find the worksheet that I have attached for you on Google Classroom. You will find these questions and all of your answers, and please just let me know if you need any help. And also on that second task, we're going to be very careful. So for example, on question I, you will notice that this left hand side of this ratio, it's in pounds, and the right hand side of this ratio is in pennies. If you have questions where there's two different units, before you start, you're going to make sure that both sides have the same units. So one way you could do it, you can convert £3.50 into 350 pennies. So that's just a hint to start you off. Okay, so any problems, just send me an email or write me a message on Google Classroom. Thank you very much, guys.